unlike this idealized diagram that you see here, the real fossil record is mostly marine organisms. 95% of all fossils are marine invertebrates, primarily shellfish. 95% of the remaining 5% are plants. 95% of the rest are fish. Most of the rest are insects. Far, far less than 1% of these are actually vertebrates, land vertebrates. And when we find them, we most often find them associated with marine fossils. We also find fossils that are extremely well preserved. Extremely well preserved. Fish like this, whose skeletons are fully articulated or still all attached together, flesh and all. Fossils like this are very, very common. A fish, when it dies, isn't going to sink down to the seafloor like this and remain there as it slowly becomes covered with sediment and then eventually become a fossil. Like I say, organisms when they die are picked apart by scavengers. The skeleton will become disarticulated and the rest will be turned into dust by your decomposers, bacteria and fungi, etc. For a fossil like the one we just saw of that fish to be fossilized, it has to be buried rapidly and was probably killed by the sedimentary flow that ultimately buried it, preventing its decomposition and later allowing it to be fossilized. This is a much better scenario to explain fossils like that and how they form. And we find lots and lots of fossils in the fossil record that are extremely well preserved like that. It's a fossil of a fish that's actually in the process, was buried by sediments and later became a fossil before it had time to finish its meal. Notice it has a fish in its mouth. This fossilized ichthyosaur, an extinct type of shark, was actually buried by sediment, became a fossil before it had time to finish giving birth. Extremely well preserved animals can be found in the fossil record. Very, very delicate structures, wings, such detail that we can identify them by species. Even the most delicate of wings and eyes are preserved in the fossil record. Animals that are extinct, we learn about them. Their fossils are so well preserved. The trilobite, an extinct animal, had very unusual compound eyes. We know what its eyes were like. We know how its eyes were designed by studying its fossils. They're so well preserved. This one was buried by sediments before it had time to pull in its eye stalks.
Darwin knew that if his theory was true, the older rock strata directly beneath the Cambrian layer should reveal a progression of fossils connecting simple earlier forms to complex animals like trilobites through a trail of incremental steps and failed biological experiments. Such evidence would document the trial and error process of natural selection.
But Darwin says in The Origin, where are these transitional forms? They're not there in the fossil record. What we see instead are fully formed, discrete groups. Now that's a world-class puzzle for someone like Darwin.
And this is kind of a common theme for the fossil record. Not only do we not see these slow and gradual progressions represented in rock records, but we have these enormous gaps between organisms. Major phyla like the cnidarians and your echinoderms, your mollusks and your arthropods, there is just no indication whatsoever what these evolved from, or furthermore what they evolved into. One of the most popular evolutionists of our day said this: "The extreme rarity of transitional forms in the fossil record persists as the trade secret of paleontology. The evolutionary trees that adorn our textbooks have data only at the tips and nodes of their branches. The rest is inference, however reasonable, not the evidence of fossils." It's a trade secret of paleontology. David Berlinski has received a PhD from Princeton University and has taught at Stanford and Rutgers, City University of New York, University of Paris. He has some comments on the absence of transitional forms.
The question has to be raised, as it should be raised whenever an evolutionary sequence is mentioned. What are exactly the predicted properties one would expect to find as one passes from a land-dwelling creature to a sea-dwelling creature? Specifically, how many changes are required to go from a creature such as Ambulocetus natans, which seemed to have been a land-dwelling creature, to a creature that spends the entire portion of its life in the ocean. Curiously enough, this is not a question that evolutionary biologists ask a whole lot. I did some back of the envelope calculations myself, and the most modest estimate I could come up with is that an organism requires roughly 50,000 morphological changes to adapt itself to the open-going ocean. And as soon as we introduce a quantitative estimate, however loose, however flabby, however spontaneous, then a great deal of puzzlement starts to intrude into the otherwise sunny picture. 50,000 changes, and we've got 2 members of a sequence. Where are the other 49,999 members of that sequence if Darwinian changes are incremental and they're small? After all, we're not talking about changes that are arbitrary. A creature must have these changes if it's to survive in the open ocean. And any attempt to put a quantitative number should induce a profound sense of perplexity, because the number of changes are so much greater than anything we see in the transitional record. Now, what is the proper explanation for this? Please understand, I don't have it. But neither do the other guys. Neither do the other guys. And in my opinion, they refuse to recognize the legitimacy of the question. That is a fundamental question in paleontology. How many changes are required? Can those changes be compared to the fossil record? And if they are compared to the fossil record, why do we see such deficiencies in the record as compared to the necessary changes? Very important issues.
Very important. I mean, the transitional forms simply are not there. The slow and gradual progression that Darwin theorized had happened to explain the life that's now on Earth simply cannot be verified by the way of the fossil record. Instead, what we find are distinct groups of organisms. We also find a great number of just what was called out-of-place fossils. We have to remember that diagrams like this just are illustrative of a general trend. There is a general trend, a sorting that took place, but you can always find these fossils completely out of place. In 2005, this mammal was found with a dinosaur in its stomach. Now, you have to perhaps have a skilled eye to recognize that to be a dinosaur, but that's what it is. This thing had a dinosaur in its stomach. And why this was particularly shocking is because when this was discovered, it was believed that mammals of this size did not live at the time of the dinosaurs. We have to understand that those diagrams we see are really just a depiction of what evolutionists expect from history, what they expect from the fossil record. In order to convince them that their view of the fossil record is incorrect, you literally have to find one in the stomach of another. You know, for them to be convinced that humans lived at the time of the dinosaurs, you will literally have to find a human in the stomach of a dinosaur, or perhaps vice versa. There are also a great number of living fossils. Not only are the coelacanth and the woolly pine living fossils, but we find a great number of these. The list that I have here are organisms that are dated to have lived more than 100 million years ago. But this list is extensive. The stingrays that we find in the fossil record are identical to the stingrays we find today. Squids are identical. Lobsters, identical to those we find today. Cockroaches as well. Shield bugs, or what you might call stink bugs, are identical to those we find today. Frogs, bats, again, lizards, centipedes, spiders, flying ants, snakes, turtles, crickets, scorpions, flies. The list just will go on and on and on. Probably one of the most substantial problems with the fossil record in supporting the theory of evolution is known as the Cambrian explosion. Called the Cambrian explosion because at one point in time, life just burst onto the scene. Referred to in this Time magazine article, Evolution's Big Bang. The Cambrian explosion was a sudden appearance of life that occurred in the layer of rocks we call the Cambrian. At one point in time, with no evolutionary transitions to suggest where they came from, most of the major invertebrate phyla just appear on the scene in a burst.
Darwin acknowledged a problem that defied explanation: the Cambrian fossil record. Here, the basic body plans of major animal groups that still exist today, and many others now extinct, made their first appearance in the fossil record so suddenly that biologist Richard Dawkins noted, It is as though they were just planted there, without any evolutionary history. Since Darwin, excavations on every continent have revealed the magnitude of the explosion of life, an event that was clearly global in scope.
These layers that you see in Grand Canyon, the layers of rocks that contain fossils, are laterally continuous. One of the laws of stratigraphy is known as the law of lateral continuity, which basically states that the layers of rocks that contain fossils basically extend forever, until they are either truncated by some geographical barrier or taper off at the continental shelves. A great many of these layers can be traced all the way across North America. There's the Grand Canyon and the layers of rocks that are exposed in the Grand Canyon and where these can be traced from Arizona all the way to Utah. The layers of rocks that contain fossils are vast in the extent to which they cover continents. Yet we cannot find sediments forming like that today. Sediments are the particulates that are eroded by actions such as water and wind, the little particulates that are being carried by a stream, and when that stream empties into a large body of water, its velocity slows and the sediments that it was carrying will fall out of solution and form what's called a river delta. A big fan-shaped deposit will form right there. They form in other ways, but generally they're very localized, form in very limited spans. They don't cover in hundreds of miles of space like this.